Hello everybody and welcome back. In this video we'll be discussing problem 3 of the 2020 AIME I. The problem reads, a positive integer n has base 11 representation ABC and base 8 representation 1BCA, where A, B, and C represent not necessarily distinct digits. Find the least such n expressed in base 10. So I'm going to write the representations that they gave us on the screen. So we have A, B, C in base 11. And 1 BCA in base 8. Now we can easily write these representations in base 10. So we have A times 11 squared plus B times 11 to the 1 plus C times 11 to the 0. And over here we have 1 times 8 cubed plus B times 8 squared plus C times 8 to the 1 plus A times 8 to the 0. Now we can evaluate these, so we have 121A plus 11B plus C. And this is 512 plus 64B plus 8C plus A. Now we know that these are equal since the problem told us that the positive integer n has both these representations. So we can set these equal, and rearranging we'll get that 120A plus 11B minus 64B, which is negative 53B, so that would be negative. So this would be negative 53B, and C minus 8C, which is negative 7C. And that's all equal to 512. This equation is really helpful. We know that A, B, and C have to be integers and greater than or equal to 0. Thus, negative 53B is negative, and negative 7C is also negative. Thus, 120A has to be greater than or equal to 512. Equal to is impossible in this case since 512 does not go evenly into 120, and A has to be an integer. From this inequality, we find that A is greater than or equal to 5. We want to minimize n, so we must minimize a. The smallest a can be is 5, so we know that a is 5. Plugging this into the equation, we get that 600 minus 53b minus 7c is equal to 512. Moving this 512 to the other side, we get that 88 is equal to and 53b plus 7c. Now we can just guess and check. If you do enough guess and check, you find that B is equal to 1 and C is equal to 5. However, this is not our answer. We want to find the least such n expressed in base 10. We know that A is equal to 5, B is equal to 1, and C is equal to 5. So we want to convert 515 in base 11 to base 10. So this is going to be 5 times 11 squared plus 1 times 11 to the 1 plus 5 times 11 to the 0. Evaluating this, we get the answer of 621. And this is our answer, and we are done.